least likely one, so that really, if I get it, then I'm the only one with bragging rights.
I know, I bet you're shocked.
But you're talking about the elephants?
Just did one.
It's great.
I'm shocked that I got so good again, if I'm shocked that.
I spent way too much time on this animation, but it was fun.
Oh,
You're not. Oh, wait, yes.
ew.
That hamburger candy corn.
What's the
What's the matter? Are we good? What is
You know that candy.
crushed candy?
No.
Candy corn, except it's grow 20% being corn.
Oh, James, I wouldn't.
Don't. Hamburger. Put it down.
Yeah, it's not, it's honest candy.
Class is like,
No, give me one smart popcorn.
so it's gonna be.
Which flavors? Yeah.
I don't know.
This one for fries.
Are they like birdie bots but candy corn? That sounds crazy.
And they go.
Is that what it is? It's like birdie bots but candy corn?
It's better than normal.
Yeah. There you go. Weirdness.
Hard. Why? are you
Okay, this
trying
doesn't
to-
want to work, so I'm gonna shut her down. Yeah,
I don't.
got some new internet business. All right, gang. Are we ready? We're gonna do a very quick review because I want to have time to do some Jeopardy today.
Okay.
Admire my animation. Admire the things you learn to do with PowerPoint. Thank you very much. I think it's amazing.
How long did you do?
Too long. I don't know. I probably spent an hour on that just because I was in a mood to not get up and do anything, and that was kind of fun. All right, so we're gonna do the marine environment, and we're gonna do it pretty quickly. So be ready. I have change in my hand. Ooh, that one's Canadian money. I don't think that'll work. All right, here we go. Here we are. So the shore, we're going to start talking about the shore. Everybody's visited the shore before, whether it's the shore of a lake or the shore of the ocean. And in this case, we're speaking specifically ocean because you've never been to an ocean? No.
From Mexico.
Oh, there you go.
Once when we were two.
So when we're speaking in this particular lesson, we're talking about marine environment. That's different than aquatic. Aquatic is any and everything dealing with water. Marine is specifically the ocean. So when you hear marine, it's talking about the ocean. However, words like marina are derived from marine, and that kind of goes for a boat that you stick anywhere, right? It's at a marina. It doesn't have to be in the ocean.
Marine.
Yeah, there you go. They go out in the ocean. Very good. They're supposed to, at least, but they hitch rides with the Navy. Yeah, and the Navy teases them about that, and then they tease the Navy, and it becomes a thing. All right, so the shore. You got different parts of the shore. You got your back shore, your dunes, your berm crest, and then you have all this area where the wave action is. And when you see the waves coming towards the shore and they're starting to crash, we call those breakers, right? And if you are ever at the beach and you want to enjoy your swimming and not get pounded by waves, you have to go out past the breakers. And once you get out past the breakers, it's usually nice and smooth. So, shoreline features. The shore undergoes continuous geological changes. So, what is the area where sediment is deposited along the shore? The size of the sediment depends upon the force of the waves. Does anybody know what word we're looking for here? What do you think?
Oceanic crust.
Oceanic crest, not quite that far down. So these are called beaches. Now, they will call them, like I said the other day, they will call them beaches even when they're next to lakes and stuff locally. And that always grinds my gears because for me, the beach is the beach. And that's where I grew up. And Lake Lanier's beach is like not really a beach. But hey, and it's this constant changing happens on pretty much all beaches where there's any kind of wave action or current of any kind, even if it's not a marine beach. For example, we used to have a little beach down there at the the riverfront, but we've had enough river action that it's washed away our beach. Yes.
What about like lava pools?
The what?
The lava pools count as beach?
If they have an area around them, yes, it wouldn't be a marine beach, but if you have an area of sediment around water that's been deposited by the water, that's the beach.
No water.
Just no water at all?
Yeah, like melted lava.
Oh, no, that's not a beach. Has to have this sediment that's been deposited.
Then where did Anna?
And where did what?
where did Anna-
Where did Anakin die? I don't know. That's not my thing.
One temperature, the other.
All right, so longshore currents. So these run parallel to the shore in one direction, usually dominates. What are we looking for? Longshore, Bailey? Oh, that's a good one, Bailey. Yeah, longshore currents, that's what we're looking for. Okay, so they generally go one direction. Where do they generally go along our Atlantic coast? Does anybody know which way they generally go? This longshore current? Yusuf? South? North to south? Who says north to south? Who says south to north?
I'm gonna say south to north.
Typically, in my experience at least, they've gone south to north. I know at least where I grew up, they definitely did. If you went out in the water and if your mom was on the beach here, right, and she had a little umbrella and she's chilling on the beach here, and you go out and you're playing in the water, sooner or later you're down here. Our something was like they'd whistle and wave, and you'd have to get out and come back and run around and get back in again because you keep floating that way. So we have a longshore something, and this is the movement of sediments in the direction of the longshore current. Yusuf?
Longshore trout.
Longshore drift, but we're close. Okay, so this is the movement of sediments in the direction of the current. So if the current is always kind of going like south to north along the beachfront, you'll notice the sediment moves that same way because it's moving with the current. And how about this one? What's the sandbar? The area of shallower water, often parallel to the shoreline, begins the breaking of a wave. Liam?
Longshore bar.
Longshore bar. There we go. All right. Sounds like a fun place to be. I'm going to the longshore bar tonight. No, but really what we're talking about here is this area right down in here where you've got like this, it's a little more shallow than it would be. And then you get this rise, and this is where your breakers come in. So if you want to go and have a nice relaxing time at the ocean, you want to float and not get tossed around, you want to be like right here, right behind that. And then what are these currents that are caused by gaps in the longshore bar, Piper? Those are rip currents. Now, who watched the video? I sent home a little video. Y'all watch it? You see how you can actually see this area like this, right? And you can tell for sure that if you look at it, especially there's some great like drone and helicopter and aerial footage of rip currents. You can really see them if you're paying attention. And remember that rip currents are actually on that list of weather-related, even though it's not technically weather, but it is sort of the weather-related causes of death. Remember, we looked at that big chart. Okay, so erosional shoreline features. So this is the flat surface, and it's formed as waves erode headlands. So remember, these headlands are this coastal landform, this right here, and it's the point where land drops off. So there are some places where you have the land just drop straight down into the water rather than a nice gradual beach. Jack, is your hand up?
No.
Up, Bailey. There you go, wave cut platforms. All right, so this is like a cliff, basically, okay? So if you, what the heck did I click? Okay, so there are some places where you've got a really, really hard rock deposit, right? And as the water splashes against it over time, it's going to wear down all the rock in front of it, and then it's going to get to the rock that's really hard, and it will erode what's above it here, and then it'll erode around it, but there'll be this nice little platform here. And this is like this headlands area. This is the kind of like your big cliff, the headlands. And then this makes like a little flat area and then a cliff. So a headland of considerable size, what do we call it? Hand. It's a cape actually, but that's close enough. You ever heard of like, well, there's capes. There's Cape Fear, right? And that's in North Carolina. So a cape is just basically a really big headland. Goes on for a long way instead of like a little cliff. So they call that a cape. But it is a cliff. Like White Cliffs of Dover is a great example if you've seen them. That's a type of cape. So then we have all these awesome rock forms that can come from wave erosion. So you've got arches and sea stacks. And then you've got pillars and sea caves and windows. Think for a minute here about this window. What would cause that? Why would this be here like this? Yusuf, do you have an idea?
Probably wind erosion.
It's all water erosion, but what might cause this right here, Jack?
Not waves. Waves?
Yeah, it's all waves, but why that? Why is there a hole there? Nowhere else. Alex.
Difference in the type of rock.
Ah, there you go. So something's different about this rock here and here that will allow it to be eroded more easily than the area around it. How about over here? What's going on here? This cave. Anybody know?
Well, there might be a evil villain hideout there.
There could be. Yes. Lily?
Rise of sea level?
Okay. Yeah.
Be torturing James Bond.
They could be torturing James Bond. Yusuf, do you have anything to add?
How about the sediments in the waves or something like
Yeah, so it's kind of a mixture of both. That's a good point. So you get the wave action going on here, right? Wave action, and it starts tearing away at this wall. Starts like a little dent, probably. And again, you've got softer rock here, right? So as it breaks into this wall, it's going to create sediment, right? As it breaks down the rock, guys. And that sediment will form a bit of a beach inside of a cave, right? Alex, put them away, man. They're distracting, okay? So you'll find the harder rock that the water hasn't cut away is what's left. There are some really, really amazing pictures, guys, of these types of geological features that are totally worth like being the background on your computer. I mean, for real, some of them are absolutely gorgeous. All right, so then we have these depositional features. So we were talking about erosional features before. Now these are depositional features. So what are these sandy deposits where the shoreline is changing? What do we call them? Bailey? The beach?
No, wait, that's too short.
No,
That's too short of a space.
too short of a spot there. What do you think goes there? Caitlin, do you know?
I've already seen the beach show up before.
Caitlin says dunes. We're close. Spit. Okay, so do you remember what a spit is specifically? Do you remember what it looks like? How can you tell what a spit is? Drew? Shh, guys. Drew?
It's formed inside your mouth.
Yeah, there's that. What else? Anything else?
Did it?
So basically what you've got here is there is a change in the shape of the shoreline. So see right here, you've got this big thing that ejects out. All right, that's a change in the shape of the shoreline. So as this water comes this way, it's going to smash it. You have to envision this, right? Okay, the water's smacking into here, smacking into here. It's depositing and it's eroding sediment. And it's going to go kind of squashed around the edges, which is why you have this little beach. But there's a current. And the current is going to pull some of that sediment in a specific direction. Which way is the current going? Can you tell by this picture?
Back out.
Is it going this way or this way, the longshore current? To the left or to the right?
Right. I mean left.
Who says left? Who says right? Who says right? Who says left? Yeah, it's going to the left. Because so what you get is waves are slapping, and some of it is coming this way because the current is pulling it this way. And what you're going to get is this buildup of sand, and this here is the spit, this thing right here. So what happened right here? This is created by longshore current, and it separates it from the mainland. What's this guy right there?
Living.
Hand up, Jack.
Look in.
Oh, look. I love it. So guys, this is the barrier island. So right here, this is just a barrier. It's pulling through, but you get these little islands along. In the US, our best example is the Outer Banks. You know where the Outer Banks is? Runs like Virginia, North Carolina, South Carolina. There's a whole line of barrier islands. If you look, you can see how over here, you probably used to have this. And now you have this. Because it's going to reach, this one eventually will reach so far that it'll touch here and you'll have the same thing. And then the lagoon is what's left here. So when a spit closes off a bay and forms a lagoon, this guy right here is a what? What is it? It's right there. When your spit is going to close off a bay, these are all bays, and it forms a lagoon, it causes a, what? It calls, Bailey.
Bay barrier.
There you go. There's your bay barriers, or bay mouth barriers, or bay barriers, or however you want to do it. So yeah, that's what this is, right? That's what this is here. So you get little islands, bing, 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 along the area, and then you get a spit. These spits here can form islands, or they can cause these barriers that close off and make a lagoon. A bay is any piece like this that where the water kind of cuts into the land, and it's usually can be tidal, but the waves are not as big because it's kind of been protected from some of that, and it's further inland. What's an example of a bay in this country? We've got a couple really big ones. Alex?
Wherever Boston Tea Party took place, I can't remember the name.
That's shoot. Yeah, it's not Boston Bay, but yeah, you're right. You're correct. That was a bay. Where else? Jack,
Marina Bay?
where's that?
No, wait, no, hold on.
There might be someplace. I just don't know. I'm asking. Do you know? Anybody else have one? Drew?
It's in-
Wait, is the bay is the part where it cuts into the water?
Yeah, no, the bay is the part that cuts into the land. Yeah.
I think
Mm-hmm.
it's in Auburn.
Yeah, so it's like
Okay.
water on three sides, right?
Yeah, pretty much.
But North and South Korea consider the big bay.
No, not really. Because there's, well, I mean, maybe, I don't know. I'd have to look and see. I'm not sure. I was asking about here, though. What do you think? You got one more?
Let's go to the other coast. That's San Francisco.
San Francisco Bay is probably one of our best known. How about Chesapeake Bay? Oh, yeah. Everybody knows Chesapeake Bay. Not too far from here. Well, compared to San Francisco, at least. So then you get this ridge of sand that forms between the island and the mainland, and that's Tombolo. Okay, so that's what you got right here is this guy right here, this long strip of sand that is going to connect this guy to that guy. Sometimes these are so well constructed and solid that bridges and, houses and things are on them, but a lot of the times you can just kind of see it like that. So know that these features can change, especially these ones that are all sand, this guy, that guy, and they can change with like one storm. Willoughby spit was the one that was closest to me when I was a kid. That was like the best known spit. And a couple years ago, there was a big storm and it absolutely changed the geography of an entire part of town, like overnight. It was very interesting. Yeah.
Wasn't there like a hurricane island, like in the book they showed like a barrier island that got totally destroyed?
In what book?
Science and geology.
Oh, there might have been. You're right. There might have been in there. Okay, so this is a little narrative that kind of explains what happens. So most what are constantly changing, Piper?
Seashore?
Most seashores are constantly changing due to, Alex?
A variety of things, including constant movement from waves.
Well, what's going to go here?
I'm not sure.
Caitlin?
Storm waves?
Due to wave erosion, so that's pretty darn good. Due to wave erosion, transport, and what deposition, Yusuf?
Sediment.
Sediment deposition. Good. All right. All right. Large storm waves pick up sediments and what? What do they do with sediments? Milo? They deposit them. That's right. Okay. And deposit them wherever waves and currents move more slowly. Sometimes the transported sediments build a narrow bank of sand called a somebody in the back, Milo again. Called a spit. There you go. That projects into the water from a bend in the coastline. All right, somebody else that hasn't answered. Longshore current may also deposit long ridges of sediment to form a chain of what? Who hasn't answered yet? Who hasn't answered that knows this one? To form a chain of, you can do it.
Sand.
No, wait, I was asking Sky. We were talking about the Outer Banks or what? What are the Outer Banks? They're a long chain of, think about it. Have you seen them? Barrier islands. That's what we're going for. You need to take a vacation to the Outer Banks. So barrier islands, tides, and what can help currents build features? Somebody who hasn't answered me. Parker, Chloe. Who hasn't answered me yet? Who knows? Come on. Tides and what? Tides and what? Chloe, tides and what can help currents build features that rise well above sea level? Gonna guess?
Can I?
Storm waves. Ah. Wait on. I know that you know. Just wait. Okay. And also winds blow dry, expose sediment into what along shorelines? Parker, you can do this. What's along the shorelines that sediment is blown into? Dry sediment blows these along.
Sand?
Sand what? You're close. Yeah, there you go. Okay, so dunes. Something about dunes. When you're visiting a beach or whatever, stay off of them, right? Usually there's a sign that says stay off the dunes. One, if you screw them up, it messes up the natural barrier that keeps everything beyond the dunes safe from ocean waves, wind, stuff coming crashing in. Secondly, they are a nice little like a little mini ecosystem in there for all kinds of critters that need to be left alone. The dunes are often held together by seagrass. I'm sure you've seen that, right? Dunes and pictures. Even if you haven't been to a beach, you've seen dunes and seagrass. So they kind of help hold them in place, just like we talked about runoff and grass and roots holding ground in place. So human impacts on shorelines. Okay, there's lots of them. Here's our IPCC again. Didn't they talk about that a lot in this last video here? So we have things like land claims. These are when people come in and they go within tidal basins or bays and they take the land back. So it used to be part of the bay, but they build it up. So now it can be bless you, a chunk of land for a factory or whatever. You see this a lot with shipping yards, naval bases, things like that, where they need to be on the water. Sometimes they will intentionally extend the land past its normal point, and that's a land claim. Then you got things like river engineering. Okay, perfect example of this nearest by, James.
Yeah.
Yeah, Beaufort Dam right there. We've now engineered a river. Now, think about it. The Chattahoochee River used to flow from Hall County straight down through here, just a river. And then we built a lake. Why did we build the lake? Hydroelectric power. And that's all part of this river engineering. We engineered a river to create power where there wasn't quite enough water flow before. So then you have things like gas mining. Sometimes they'll do fracking. Y'all know what fracking is? It's like using a bendy straw instead of a straight straw, right? To get gas out from underneath the surface of the earth. Then we do all this vegetation clearing. We do this all the time, right? We mow stuff down. Coastal engineering, again, this is more like coming in and instead of just in a bay, now you can come along in the ocean and build out the land. And then you've got dredging. Now, dredging is something we do sometimes for the purpose of making it better for our ships and whatnot to move through. And then sometimes we do dredging with the intention of trying to preserve some part of the coastline. You remember the picture where we had like the cross section of the coastline and we had that longshore bar and then there was a slightly deeper part before you get to the land? Sometimes that gets kind of filled up with sediment and they will go through and intentionally dredge or dig it out and move it to another location. Sometimes they'll dig that out and then dump it where the dunes are supposed to be. So they're taking it out of the water to kind of put it back the way it's supposed to be and then rebuilding the dunes the way they're supposed to be. So sometimes they'll do that sort of thing, which is helpful. It helps. And some beaches, like probably most of the beaches that you would vacation on, a great number of them intentionally replace sand because it moves with time, and the people whose income depends on tourists can't have the beach be 20 feet wide one day and then 100. They want a certain consistency, so they'll dump sand on purpose. All right, so here are some structures that humans build to protect either the area beyond the seawall or in that area in general. So what do you call these right here? These are built parallel to the shoreline, and they're there to kind of reflect the energy of the waves away. Milo. That's a seawall. Okay. In 2005, we had a major seawall failure in this country. Does anybody know what it was?
The levees in New Orleans.
Yes, sir. What happened?
Hurricane Katrina basically wiped them out and it all flooded New Orleans.
Yep, there you go. So there were lots of seawalls, which are levees, and they were all around the city of New Orleans and Lake, what is it called? I can't remember. There's a lake right there. The water level got really high, and then also all the water from the ocean and the force of the waves from Katrina just pulverized them, and the whole city flooded. We're talking like city streets with people in boats because the water was like yay deep everywhere. Okay, so underwater and parallel to the shore, and they're there to disrupt the longshore current. What are those, Liam?
Groins.
This guy right here. Okay, that's a groin. Why is it called a groin? I don't know. It's terrible. Whoever did that should be ashamed of themselves. That's really awful. Why? Some people do weird things. All right, these are concrete walls. They protect harbor from drifting sand. Yusuf,
Breakwaters?
breakwaters? No, this one right here. Look at this one right here. Concrete walls that protect harbor from drifting sand. Right in here. Let you get into the harbor. Do you know? Do you know? Jetties. Okay, so these are jetties. All right, now you can see right here where they've built some. And this estuary area, this is going to be where you're going to have a harbor, right? You're going to get some boats and dock them up in here, and that'll be cool. But if you let this longshore current going this direction, right? If it moves this sand continuously, it could close off your inlet. So you build jetties to protect that. So then this last one, these are built parallel to the shoreline. All right, Caitlin.
Breakwaters.
These are breakwaters. All right. And you can see that it's kind of, the point here is to sort of slow down some of this business, right? And it's to keep some of the erosion from getting, completely out of hand and just kind of keep your beach. So what are these? These provide natural coastal protection against storm surge, high waves, preventing or reducing coastal flooding and structural damage, as well as important ecological habitat. We just talked about it, James. Dunes, right. Okay, these are not man-made dunes. These are not, that's what you said, you're so quiet. So these are not man-made, these are natural, but we do often promote dune health by adding sand back to the dunes. Another interesting thing, growing up, I didn't drop as many this week. Growing up, there was one thing we could do back home that we can't do here, but I kind of wish we had some way to get everybody participating because it works very well. When they have these like take back your Christmas tree after Christmas, when your Christmas tree is dead and you give it to the Boy Scouts or whatever. In Virginia Beach, what they did is they dropped them in the dunes all along because they help prevent erosion. It's really smart. Like if we could get Christmas trees for more and more people endless, so we had like endless trees to stick along all the dunes all along the coastline, that would be super good. Because they think about it, they're all like branchy and you stick it down there in the sand and it becomes part of the dune system. It's a very, very smart thing to do. Super clever. So changes in sea level. So sometimes it's believed that climate change caused by global warming is causing sea levels to rise. Their theory is informed by thermal expansion. So when global temperatures increase, this causes what to heat up and expand and lead to a rising sea level, Drew? Yeah, water. Okay, so your water is going to heat up. It's going to expand. Oops, what happened there? They were out of order. Sorry. So your seawater is going to heat up. It's going to expand and your sea level is going to go up.
And it also melts ice.
Yes, that was the next thing. Those clicks were out of order there. So yeah, melting glaciers is going to add to the sea volume. So think too, though, for a minute, melting glaciers, yes, because they're on the land. Would melting icebergs increase the sea volume a whole lot?
Stay into the water already.
Right, because think about it. What's a little micro experiment that could show kind of how much it would increase, if any? Yeah, put a glass of water, put some ice in the water, watch the water level. How much does it change? Only a little bit by what's above, right? What's floating above may adjust a teeny bit, but it's not huge. So anyway, this is the basic concept that we've seen it now in these two documentaries. Water heats up for whatever reason, depends on who you're asking, right? Water heats up, water expands, sea level rises, glaciers melt, sea level's going up. So, come on, I clicked you. Where are you going? Oh, okay, there we go. So the sea floor. Yes, Drew.
Wouldn't it also increase sea level if it got colder because hydrogen and expand the water?
Okay, so hydrogen bonds and like ice. Okay, so it would have to get really cold. And I mean really, really cold, because think about it, it's salt water. So 0 Celsius isn't going to be cold enough to freeze the salt water. It's going to have to be colder than that. And it would have to be colder than that for a huge, huge, huge volume of seawater in order for it to freeze and then expand. Because frozen water does expand, right? Because the way the hydrogen bonds are situated, it'll click into place and make this crystalline structure. And that's why you can't put a bottle of water in the freezer and it'll swell up. All right, so you've got your seafloor. Now it's usually singular. We usually say seafloor, not seafloors, despite where you're talking about, even though, we kind of say oceans and we divide bits of our watery planet into chunks. We usually kind of throw the seafloor all into one. So this is the solid surface underlying the oceans, and there's all kinds of features. You get this continental shelf, which comes off of all the continents, there's an area that's much more shallow. And then when you get out into the deep sea, you get things like these canyons, you get continental slopes, you get trenches, and then you get these sea mountains. It's amazing. It's just like if you took the surface of Earth and plopped it down under the water. We have similar features everywhere, right? Here on Earth, and then we have them under the water as well. So what is this one? Continental something. It's where the edge of the continent meets the ocean. Yusuf.
Continental margin.
Continental margin. There you go. Where the edge of the continent meets the ocean. So that's this whole area right here. It's a big area. So then within it, there are going to be other like kind of sub features. So what's the shallowest part of the continental margin, Liam?
Continental shelf.
Continental shelf. You can see it right here, right? That's the shallowest part. So then what's beyond the continental shelves is where the seafloor drops away really drastically. Suddenly it's dropping away. Lily, you can see it, can't you? Where just beyond this continental shelf, what's the area where the seafloor just drops? Yeah, you're pointing at
I know.
continental slope, right? There you go. She's like, it's that right there. Yes, continental slope. Mhm.
I can't see it.
It's right here. So that's this area right here. And the seafloor just drops away rapidly, right? And then lastly, or continental slope, that's what we said. Where's the sediment deposit at, that should say base, whoops, of the continental slope? What you got? Continental rise. Okay. So when we get talking, I think one of my favorite parts of this whole class is when we get talking about seafloor spreading. It's going to be super, super interesting. And you'll see how all these parts play in. But the stuff you learned about tectonic activity and seafloor spreading, it's pretty cool. There's actually proof of pole switches in seafloor spreading. So what are these? These are currents, and it's heavy sediment. They're loaded, heavily sediment loaded currents. They move rapidly along the seafloor. They're like mudslides on land, but they create canyons. Do we know what these are? Liam?
Turbidity
There
currents.
you go, turbidity currents. Okay, you've heard the word turbid before, or turbidity. Kind of goes from like turbine. What's a turbine do? Drew?
Well, I mean, there's water and there's air, but it basically moves fluid.
Mhm.
Fluid.
Really fast, like, right? So yeah, you get these turbidity currents, okay? And they cause all this loose sediment to get picked up and whooshed out this way. And in the process, they create canyons and other structures underneath the water. You can almost think of it like wind erosion, but water erosion underwater. Okay, so deep sea basin. So now we've left like the edge and the shoreline, and now we're like really into the deep, deep sea. So the flattest part of the ocean floor, what do we call that, Bailey?
Abyssal plains.
Yeah, okay. Abyssal plain. Okay, so that's really down there. Who's seen the movie The Abyss? Anybody seen it? It's an old school 90s sci-fi movie. It's really cool. Basically, they get down to the bottom and they're down there in the abyssal plain doing whatever science experiment they're doing. And they find like these alien creatures that live down there that we never knew were there. It's like part of our universe or part of our, that we didn't know were there. They're like these bioluminescent critters. It's really interesting. It's kind of like, well, I don't know, sort of it is, but it's not extraterrestrial, but it's alien, meaning uncommon. Who's seen Contact? You've seen Contact? Anybody? Oh, y'all got to see that one. Okay, that's similar in sort of theme overall. So this next one, deepest features. Yeah, Yusuf.
Deep sea trenches.
Yeah, your deep sea trenches. The best known one here is your Marianas Trench. Where's that? Anybody know where it is? Marianas Trench? Drew, do you know?
Like off close to.
It's not quite coastal, but yeah, like what ocean is it in?
Like the Pacific.
Pacific? What ocean is it in?
Pacific.
Pacific?
Like the Caribbean. Right?
Yeah, it kind of runs. Okay, so I'll show you. Is it on here? It's on here.
Isn't it to the right of South America?
I'll find it for you I'll show you on a map so you can see it. All right, so what is this right here? This is where major tectonic plates meet. And you have a lot of volcanic activity and earthquakes here. Alex?
Just any cross line, Billy.
Yeah, they're called mid-ocean ridges. Yeah, and they're ridges because your tectonic plates are meeting, right? And they're meeting there and they're pressing upward. Whereas in your trenches, they're not meeting, but they're doing what?
Separate.
They're moving away. So you get fluid heated magma being forced upward in these areas. And what do we call that? Anybody know? Milo? Yeah, hydrothermal vents. So you get fluid heated by magma, because there's a lot of, like we said, volcanic activity there. So hydrothermal, there's a word, hydro, water, thermal, heat, temperature, hot water. Hot water's flying up out of the crust underneath the ocean there, out of the seafloor. So it's a hydrothermal vent. There are some organisms that thrive in that environment. They live in super hot water because that's how they live. And they're cool there, huh? Yeah, there's all kinds of critters that's just their thing. So, what's this next one? Do we know? I think I spelled that crazy there. The next one is supposed to be seamounts. It's supposed, I don't think it finished. It's supposed to say submerged basaltic features. So basically the seamounts here are mountains. Hang on, you're good. Are mountains that are under the water. They're part of the seafloor, and they're built from volcanic activity underneath, or from at least, maybe not volcanic activity, but magma piling up, right? And then lastly, large extinct basaltic volcanoes with submerged flat tops. Drew. Yeah, okay, Guyot, that's that right there. All right, so what that is just exactly what it sounds like. It's this extinct volcano. It's got a nice little flat top there, and they just sit there like little plateaus, right? Underneath. So marine sea what? I can't even see what I wrote. Sediment? No, is it sediments? It is marine sediments. So what are the sediments from earth and rock that's more terrestrial? It's up on the surface, the shoreline. All right, Yusuf, what is it? All right, these are, come on, there it goes, terrigenous. That's another one there. Okay, look at that word. Genus or genesis or Jenny, that often means having come from or derived from, right? And then terry means what? Or terra, huh? Yeah, that's a different one. Yep, same thing. But yes, it's the same root, but you're correct. That word is used there too. Terry or terra meaning earth, right? Land. So they come from the land. What do we call, looking at that, okay, terrigenous. What do we call the ones that come from living things? All right, Liam.
Biogenous.
Biogenous, of course, because life coming from or derived from living things. And then this last one, these are elements that precipitate directly from seawater, Bailey.
Hydrogenous.
There we go, hydrogenous. Yep, same thing. So that's what you get. You get these little guys that precipitate out. There are some spots along the seafloor that have like little, like magnesium, I think is one that makes these little like blobs almost along the seafloor. It's kind of weird. And then lastly, these authogenic. Okay, I don't think this one was in your book. Does anybody want to try and guess what authogenic would be? So genic and genus are the same kind of thing here. So what you're looking at now is the root here, auth. What is that? Anybody want to guess where that comes from?
Gold.
Gold, that's a good one because there's AU, but it's usually AUR or AURAL, somewhere in there. Auth. Where's it? What's a word that contains AUTH?
Authentic.
Author, authentic. Okay, so what do you think that would mean if it's author or authentic? What does that say to you? Author, authentic. What do those words have in common? Like
Creator or something.
created by who? Think about it. If you're an author, you're creating it, right? Created by you. So what do you think authogenic would mean?
Man-made.
Created by, where are we talking about? We're talking about the ocean's floor. Created by the ocean's floor. So sediment that's been formed in place by the seafloor. Very good. That's exactly what that is. So good job taking that word and breaking it apart. All right. So last one. Oh, we did this one already. Huh? Don't need it again. Hello. Sorry. Okay. These will be up for you to see. So now we're going to do Jeopardy. So I'm going to do, how am I going to divide you people? Let's see. All right. We're going to do, okay, don't get too loud. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, Lily's 5. All right, Drew and Caitlin, you're on that team, the breakfast room team. Okay, so Drew and Caitlin are over there. So go over there. If you go over there, Drew. Well, no, we got 1, 2, 3, 4, 5, 6, 7. So I have the living room team and the breakfast room team. All right. So
I think this is.
here's how we're gonna play.
Can we do team A and team B?
Well, yeah. So we got living room team and breakfast room team. We're gonna start by a coin flip. Let me see. All right, so I'm gonna flip a coin. All right, who's a captain? You gotta pick a captain. James? James and Alex. Alex.
Okay, I guess I'm the captain.
Okay, I'm gonna flip. It's gonna be a head or a tail. Your tail and your head. So
Okay.
and whatever it lands,
You go first.
you get to decide if you want to go first or second. Okay, ready? Okay, it is heads.
Okay, I'm going first.
We're going first. All right. So here's how it goes. It goes to this team. You get nee, 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 bum, 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 bum. We can't get too loud. Remember, Jason's working. Okay. And then if you don't get it, we will give the other team the opportunity to catch it. Other team. So what I'm going to do, listen, don't get too loud here. What I'm going to do, instead of Jeopardy theme, I'm actually going to put on my little stopwatch here. Or no, my timer. And I'm going to give everybody, are you listening? You listening?
Yes.
You're going to get, if you're starting to think, oh boy, what am I going to do? You're going to get like 30 seconds to answer the question. Okay. And if it has to bounce back to the other team, they'll get about 15 seconds to answer the question. Okay. So going first, are we ready? Here are our categories. Bum, 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 bum. If you've practiced, you're good to go. All right. Alex's team, where are we going first?
How to science 700.
How to science 700. Remember to answer in the form of a question.
What is a question?
Okay. An open water bottle is an example of this kind of system.
It's not close, it's open. I think it's completely open.
Because it can exchange.
I can change everything, so I think it's just
So
open.
this would be an option.
Do you have your answer?
What is an open system?
What is an open system? And you are going to be, come on, click. Oh, space bar. There you go. What is an open system? Very good. I always forget it's the silly space bar. All righty. And we're going next. All right. Where's the little button? Shoot, shoot, shoot. Let's forget which one goes. All right. And you have to keep score. Somebody over there is your scorekeeper.
I'll be scorekeeper.
Okay. But because I'm going to do it. Because I'm going to do it, but I'm not always going to do it right. So just make sure I'm doing it right. Okay. Team at the back.
Rocket 7.
Rocket for 700. Ultra basic rocks are high in this element.
Basalt isn't an element.
I was hoping so. Oh, silica. Yeah, sure. But it's silica.
What is silica? All right.
I just told them that basalt wasn't.
I'm going to throw it to the other team.
Oh, wait, they answered.
Yes, they answered, but well, okay, we'll not throw. So we have more time. So, whoops, I'm sorry. Hold on. We won't throw it. So we have more time. We'll just stick with one team answer. So your answer is going to be iron. Iron. So no points for that one. All righty. On back. What's next? Alex's team.
Fair weather for 700.
Fair weather. I love you guys are going for the 700s first. Fair weather for 700. This is what a tornado might look like on a weather radar. Ooh, you have to think about this one. What is this circle?
You know what? We'll keep that for a second. What is
And
9, 8, 7, 6.
Spiral.
What is a circle?
What is a circle? What is a spiral? Okay, now we didn't really specifically go over this in class, but you might want to pay close attention to this answer. So you got a thunderstorm that develops. That's what looks like your circle, right? Or your spiral. But when you get a hook that appears on the edge of the storm, it looks like a hook. That's when your storm is intensifying, and that little hook can look really obvious on radar. So if you were to see on your midterm a weather radar picture with a big old hook on it, and you were asked, oh my goodness, if you see that, what do? What would you do?
Run away.
Think about specifically how you would think about it. Study this. How specifically do you need to keep yourself safe from a tornado? Okay, look it up. Look it in your notes. I'm telling you, you might want to know it. All right, check. Who's James's team? Let's go. What you got? Oh, I gotta put. No, I know. Let's go and check. Blue planet 700. So these blue planet ones tend to be water related questions. Okay, here we go. This is the second leading cause of weather related death.
Oh.
Oh, 10 seconds. You got your answer? What is a riptide or rip current specifically? Flash flooding. Rip current is not second. I'm sorry. There's my timer. It's third. Rip currents are third. Flash flooding is first. Sorry. Yeah. So you guys were close because I mentioned it during the lesson, right? I mentioned it's one of the leading causes. Look back at that little, you remember the graphic? You may want to get an idea of what like maybe the top leading causes of weather related death are. You might want to look at that. Might just maybe. Got it? You hear me? Okay. What's next?
Find your way 700.
Find your way 700. Okay. This is located at roughly 180 degrees longitude.
Longitude is. Okay, it's no longitude. Longitude is equator, longitude, and latitude. That's all I need to know.
Yeah.
Wait, no, I know this one. Yeah.
Wait, I don't.
Latitude is the latitude.
Longitude is how far around it is. Longitude. It's.
10 seconds. What's it? 180 roughly 180 degrees.
International date line.
Very good. What is the international date line? All right, now, Liam, that's great. So we're gonna add another 700 here. Okay, here's the thing. Why is it roughly?
It changes just.
Listen back there. You're gonna want to know this. Why?
It changes to go around the country, so you don't have. Oh, it's Tuesday here and it's Monday here.
Very good.
Or
So
it's a holiday on this.
what's it 180? Prime meridian. Okay, so prime meridian goes nice and straight like this. 0 latitude is equator. 0 longitude is prime meridian. 180 longitude is your international date line, and it goes like this because it goes around countries. Very good. All right, James, what are we doing? Breakdown 700. Here we go. The process by which a stream erodes away at the rock and soil at its headwaters in the opposite direction that it flows is called this. Very quiet.
Wait, I know what it's called. I just don't know it.
Those are my favorite kind of answers. I know it. I don't know it.
Back.
You got 8.
What is the question?
What is a back current? Nope. This is headward erosion. Okay, now, if you were not, I'm sorry. Yes, I know. I didn't hit stop. Okay. If you were not asked this exact question, this like rather definition type question, but rather you were asked a situational question in which headward erosion had caused a certain feature to move. What kind of features are really obvious with headward erosion?
Oh,
Yeah.
I believe waterfall.
Waterfalls. Sooner or later, that waterfall scoots back. Okay. Headward erosion is the cause of that. All right. Keep that in mind. You may want to keep that in my test this year. If you haven't noticed, they're a lot less definitional and a whole lot more like applicable, situational, make you think so you don't just know the answer, but why? Okay, what's this one going to be, Alex?
All around you, 700.
All around you, 700. Here we go. The Earth's atmosphere is about what % nitrogen?
It's about 70%. No, it's not.
In the book.
I'm pretty sure it's about 7.
About 70.
Or was it about 60?
I'll give it to you if you're within 1%, one direction, or the other, for the purpose of this.
Okay, I think it's 71.
About, it said about, not exactly. About them.
Yeah, we had some lots.
5, 4.
What is 71%?
What is 71%? Okay, so 78 is your answer. So you're gonna, oh God, that's loud. So you're gonna want to remember this number. Now, it says about. So on the test, if you were to get 78, that's gonna be a full credit. But if you do something between 75 and 80, you might get partial credit. If you go someplace wackadoodle nothing, then no, right? Okay. Next, where are we going, Alex? No,
Wait.
James. It's James's turn.
How to science 600.
How to science 600. Okay, this tells what happens a fact. This tells why it happens an explanation.
What is scientific theory and scientific?
Yeah,
Like, which way?
No, you have to get them right. I need it in the,
Scientific line, what is scientific?
put it, read it for me with the this in it, so I know you got it. What is,
scientific law tells what, a scientific theory tells what.
there you go. Okay, a scientific law tells what happens a fact. A theory tells why. Yes, very good. Law and theory. Good job. So you guys got that one. Boom. All right, here we go. What's next for us, Alex?
Find your way 600.
Find your way, 600. When traveling westward by ocean, sailors take advantage of these equatorial winds.
What are trade winds?
What are trade winds? Very good. Now we're getting back into ones you guys know a little better. All right, James.
I'm going in order.
Yeah.
No.
Blue planet, 600. Seawater has a salinity of about this percentage. Again, I'll give you 1%, one way or the other.
I know this one as well. Wait, if they don't know it, we can. They were not used to can I Siri?
No, Siri.
Stop William from using the book.
They made him put it up.
We specifically told him not to cheat.
Got 15 seconds. Shh, y'all let them answer.
That's what I was thinking. What is 1 minute?
3, 2,
About 33. What is
about 33%.
Like 5%, I thought.
3.5.
Why you can say 70% helps if they trust you.
So the answer you're gonna want to give me for this, because it's such an itty bitty number, it better be somewhere around 3. It can't be above 4 and it can't be below 3. So I would just memorize 3.5 if I were you, right? 3.5 is a good number to remember. Y'all can all do that, right?
I say pi is my answer.
Pi. There you go. That'll help. It's close. All right. Yeah, 3.14. Yep. Yeah.
Fair weather 600.
Fair weather.
Although the last fair weather question for tornadoes, which aren't really fair weather, so it's
Yeah.
really fit in the category.
All right, here we go. This deflects air to the right in the northern hemisphere.
What is the Coriolis effect?
What is the Coriolis effect? Points to your team. Very good. Excellent. Everybody see that when we're good? All right, James, where are we going?
Six of shooting people.
No, he's trying.
Guys,
He's trying to cheat. He's trying to lean in on compensation.
hang on. I couldn't hear you. Wait, guys in the front. James,
Science 500.
how to science 500. Okay. In order for this to be considered, it must be possible for it to be tested and accepted or tested and rejected.
That's a hypothesis.
What is a hypothesis? Way to go, James' team. Alex's team, you're next. Where are we going?
All around you 600.
All around you, 600. This type of substance is derived from living things.
What is an organic substance?
What is an organic substance? You are right. Now, remember that on the exam, what's the opposite here? What's our opposite of organic?
Non-organic.
Inorganic, right? So remember that when you're on an exam, what you get might not be this exact question. It might be the opposite one, or it might be a true false, right? Okay, what's going to be up? James, your group. I love that you guys start with the hard ones. It's great.
It's the best way to do short points. Let's see what you got plus.
All around you, 500. A solid becomes a gas through this process. Solid gas. What is sublimation? Awesome. Now, who's been with me long enough to know my standard example for sublimation? Drew, what is it? What is it?
Put the light into it, and then because it like turns black, to say it's like the government conspiracy.
Okay, if you're new to me, this is what happens.
Funny enough.
Every year, hang on, Yusuf. Every year there is a first snow. There's always some nitwit on YouTube who's taking a ball of snow, holds his lighter up to it, and it turns black and it doesn't turn to water. And they go, oh, look, it's like plastic snow. There's a government, there's always, I promise you, every time there's always one. Either that or an old one gets circulated. Why is it turning black?
Because there's stuff other than water.
Yeah, it's the soot from the butane. All right. And it's not melting because it's doing what? It's sublimating.
That is
Every year you watch for it. You're going to see it, I promise. All right, Yusuf, you have a hand for something?
Yeah, like it doesn't carbon dioxide also do sublimation when it's
Yes. Yes. Very good. Great example. All right, Alex, you're up.
Breakdown 600.
Breakdown 600. This is a long and winding ridge of sediment formed from streams which flowed beneath the glacier. I told you guys this was my favorite glacial deposit because it's so cool looking.
Yeah, something not messy, right? Well, it's for the glaciers in Glenville. Maybe we can get that.
It's not.
What's the glacier?
Get about 15 seconds. And
Okay, what is an esker?
what is an esker? Very good. Oh, that's the wrong answer. Ooh. Okay, what is an esker is correct. This one did not get, woo. Okay, I'm gonna fix that one. Esker's right. Hang on, I'm making a note. Ooh, I gotta fix that. I don't have a thing to write on.
Yes,
That's esker. That's correct. 100%. Because those are my favorites because they're so neat looking. Do you remember the homework assignment with an esker? The longest esker on the planet was where? Do you remember? It was in Canada. And do you remember what was mined right there next to it? Yeah, there's a diamond mine right next to it. This was, what was this? This was breakdown 600.
Yeah.
Okay,
Okay.
breakdown 600. Let me make sure I add your points. All right, and we're going. Next team, James. Shh, guys, volume. James. Rocket 600. Here we go. Large crystals in a rock demonstrate this. Specifically, that it cooled slowly. Right. What is slow cooling is correct. Very good. All right. What are we doing, Alex?
Fair weather 500.
Fair weather 500. This is the second leading cause of weather-related death. We had the third. Yeah. So second and third.
We've had second previous.
Yeah, you did.
Second was flash flooding. If this is supposed to be third.
Second is flash flooding. This should be third. So this is,
What is rip currently?
so fair weather 500. Let me make, hold on 1 second.
Is the same. as-
1 second. I want to make sure that's actually right before I tell you to switch. Flash flood flash flood is the second leading. Rip current is the third leading. So this is, yes, this is the one we were going for, and it was rip current. You're correct.
That
So
are.
the other one, okay, so this one, all right, good.
That as well.
That are, yeah. Okay, I'll fix that too. All righty. Bailey, is that right? 43?
Yes.
I clicked, but I wasn't sure if it actually hit. Okay, next up, James. Rocket 500. Okay, These are 3 of the multiple characteristics that can be used to identify a mineral.
Case.
Yes. Wait a minute, hang on, you're gonna want to listen to his answer. Yep. Okay. Okay, so here are some of your options. You can give me any of these. Hardness, crystal form, streak color, special properties, specific gravity, luster, cleavage, fracture, texture. Why isn't grain size here? I'm going to give it to you, but why isn't grain size here? That's for the rock. Good, Drew. That's for the rock. This is for the mineral, like within the rock, right? All right. Where are we going over here, Alex? Blue planet, 500. About 71% of the Earth's surface is covered with this. What's water? That's an easy one. You got it. Do your thing. There you go. Okay.
You gave us points twice.
Hold on. There it goes. Sorry. I wasn't sure if I hit it, but I wasn't sure if it hit. James. Erosion, deposition.
Find your way.
Find your way, 500. Alex's team, listen. To keep the ocean on the map, it's important not to disturb these wind-blown sand deposits that separate the beach from the mainland. All right, what are dunes? All right, very good. We just talked about that just like an hour ago, right? What dunes? What dunes? Oh my gosh, have you seen the parrot that does this? Which one is this? I got to fix that one. Find your way, 500. There's a parrot. Oh shoot, I can't remember his name. It's a ringneck parrot, and he's on all these YouTube videos, and he goes, "What doing? What doing?" What you got? Did you have something? Question or? If we were doing, so I was gonna do that, but I was looking at the clock, and I'd rather everybody get one run through. So if we're doing it a second time, I would do it that way and give you a chance to steal. But this time I'm just gonna let everybody run. All right, so we're up next. Who's up? Alex?
Us.
Okay, where are we going?
Breakdown 500.
Breakdown 500. This is the process of the lowering of the land surface by wind erosion. Now I hope this one's actually right because it was the other way around.
What is deflation?
There you go. That's the one that is supposed to be deflation. Let's see, did it come out? Yes, that's correct. All right, what is deflation? Very good. Okay, oops, I didn't give that one to you, did I? I need to make sure you got it. Okay. What's up? How to science, 400. 1 milliliter is equal to this many liters. Ah. All right, so here's what you're looking for. 1/1000th or 0.001 liters. Good, very good. You have to have a metric question.
Blue planet.
Very similar. Yep, and it may not be that exact question, but it's very similar. Blue planet, 400. So this is a tributary. Tell me what it is.
What is a stream or river that feeds into a larger stream or river?
Here you go. What is a river or a stream that flows into a larger river or stream? Just backwards from the way you said it. Perfect. All right. James. Yep, James. Wait, James is gonna tell me. What? 400. Find your way, 400. Okay. No matter where you are on Earth, this causes thunder. So it's a weather question that's thrown into the map because I needed more weather questions. Not really a map question, but. Be more specific. Something, yeah.
At least 5 degrees Celsius.
Very good. Okay, so we've got, you're going to want an answer similar to this. Rapid expansion and contraction of air. It doesn't just keep expanding, it goes boom, right? Due to the heat produced by a lightning strike. I need to see the words expansion, preferably contraction, and I need to see lightning strike. Got it? Got it. All right, moving on. What's next? Alex?
Fair weather 400.
Fair weather 400. This is what happened to Becky's shampoo bottle. Oh,
Is-
who remembers?
Is that the one that went from Denver down here? Okay,
I forgot. Air pressure.
it got
What
s-
did it?
Tell me how.
The air pressure.
what is the air in Denver is lower, therefore, when it went to an area with higher air pressure, it
She wants
was compressed.
Yeah, no, that's correct. That's correct. You got it. Okay, good. So what you're looking for is an answer kind of like this. So the atmospheric pressure. Now listen, if you give me a really full answer, this is how you get this is how you get all your points, right? So your atmospheric pressure in Denver is going to be fairly low because it's a high altitude. And in New Orleans, it's going to be much higher. So what was in Becky's shampoo bottle in Denver? Yeah, shampoo and air. Think about it. If you're traveling, even if you start with a full bottle, you get where you're going, you use some of it, right? Shampoo and air, right, is in her bottle. So the contents of her bottle, which included any air, they're not exerting enough pressure because they're only exerting Denver pressure to push back against that New Orleans high pressure, and her bottle's going to cave in on itself. Kind of read over this one a bit. Get it in your head, right? Yeah, it's a homework question. Come back to haunt you. Oh, wait, I didn't give you credit. All right.
No, you did.
Did I?
Yes.
Oh, you're right. You're right. You're right. Okay, James. Break down 400. The rate of chemical weathering increases as this increases. Yes, temperature. That's what we're looking for. As the temperature increases, the rate of chemical weathering is going to increase. All right. What's up, Alex?
All around you, 400.
All around you, 400. The law of conservation of
Oh.
energy states this. I need it in full.
I know, Bailey. What is energy can neither be created nor destroyed, simply change states.
It changes form. Yep, that's what we want. Good job. Remember this one. You might want to memorize this one so you can do it word for word.
I have.
There you go. All right. What's up, James? Rocket 400. This illustrates the predictable pattern in which minerals form as magma cools. What is this thing? Shows you the pattern. Nope. This one is going to be, what is Bowen's reaction series? There you go. So if you were to see this one, on the test, you might want to remember exactly what it's called. Maybe you'd be thrown things that have a similar name, right? Alrighty. Next up, how to science 300. Now we're getting the easy ones. Using your senses to gather information is called this.
What is an observation?
What is an observation? That's great. Moving on, James.
Now we have 7.
All around you, 300. A substance in this state will have a definite volume, but no definite shape. Shh, shh, guys in the front. Shh, 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 shh.
Added one too many hours.
Okay, did I?
Yeah.
What is a liquid? You guys got it. Very good. What is a liquid? All right. Alex?
Blue planet, 300.
Blue planet 300. This is the cause of high and low tides. Be specific in your answer.
What is the pull of the moon upon the water as it rotates around the planet?
Very good. All right. So guys in the back, are you okay? Are you stuck, Myla? It's stuck? Okay. All right. So yes, here we go. You're going to want an answer similar to that, tides are just really long waves. They move across oceans. But you're going to want to remember they're caused by the gravitational forces exerted on the earth by the moon and to a much lesser extent the sun. And your highest point in the wave or the crest, when that reaches the coast, that's when you got a high tide. When it reaches out somewhere in the ocean, that's where you've got a low tide. All righty, James, what's up? Find your way, 300. Okay, this is 0 latitude. There you go. What is the equator? Very good, very good. All right. What's up, Alex?
Fair weather, 300.
Fair weather, 300. This causes season. Be specific.
What is the tilt of the Earth's axis?
Okay, there you go. Now, you're going to want to be sure that you give me good specific answer. Why is the tilt of the axis cause it? Because as it revolves around the sun, certain parts of it are either closer or farther away from the sun, and that's going to cause your periods of warmer or cooler weather.
Fluctuates periodically.
Periodically. That's a good one. All right, James, where are we going? Rocket, 300. Sediment becomes rock through this process. Yes, lithification. I'm trying to. Lithification. Very good. You should write lithification. That's a good one. All right.
Breakdown, 300.
Breakdown, 300. This is the progression through which runoff becomes a river. I told you guys to memorize this one. So good.
It's the different it goes through rivers.
There's steps.
I think it's
10 seconds.
What is real true?
Try that again.
What was the
Real,
gully? What's the first one? Trough, stream, river.
very, very close. Okay, so this is real gully, stream, river. Real gully, stream, river. Real gully, stream.
Viper.
You may want to memorize it. Make sure that you recognize it if you see it. Okay. Where are we going, James? How to science, 200. In an experiment, this is what you keep the same. What is the controlled variable? What if you saw a question and it said this is what you change?
That would be
Independent variable. And what would it be if it was if it is what is changed? There you go. Excellent, guys. You guys are so good at this. All right. What's next here, Alex?
blue planet, 200.
Blue planet, 200. All the area that drains water into a river is called this.
What is watershed?
What is the watershed? Oh, I didn't give you, James, I didn't give you credit for that. Yes, there you go. Watershed. I know I didn't give them now. There we go. Watershed. That's what you want. Are we good? All right, James, what's up?
All around.
All around you, 200. Okay, H+ ions are produced when this type of substance is combined with water. Oh, you didn't expect this for a 200 question, did you?
Each other.
H+. Those are hydrogen with a positive charge. Are produced when this substance combines with water. Everybody's quiet.
Well, we don't want to give them the answer.
Oh, you know it, do you?
Yeah.
Yeah, they're like, yeah.
Okay.
Wait a minute. James still has to answer. He's got 10 seconds.
Get a hint.
You
Hang on. I got to hear his answer. Okay, what is it?
Sacrifice.
What is what? Throw it out. Anything. Okay. All right, this is an acid. If I asked, okay, somebody tell me what do bases release in water? OH negative. That's hydroxide. OH negative.
Because that's just hydrogen.
So hydrogen that's positive are released when you combine acids with water. OH negative are released when you combine bases. That's hydroxide. If you were to put OH negative and H+ together, what would you get?
H2O.
Thank you, which is water. Very good. All right,
Fair weather, 200.
fair weather 200. This is what happens to ice when it gets about 0 degrees Celsius.
Okay, I'm gonna go way too in depth.
This is an easy one.
I'll go in this.
Let's let Alex take the reins.
What
And
is
we're gonna get that around.
to 0 degrees Celsius, the hydrogen bonds between individual
Fix this
water
one, actually.
molecules causes
You're gonna give me a very involved answer.
a specific pattern that causes it to expand and trap air, causing it to become less dense than the surrounding water.
So I see a typo in this one. It should say water, but if it says ice, if it did say ice, your answer would be what?
If it melts.
Nothing, right? But it's supposed to say when it gets above, not about. So that's what I have to fix. So when ice gets above 0, it's gonna melt, right? That's what it should say. I have to fix this one too. I got too many of them. They're screwy. All right. Coming up. I'm gonna give you credit for that one. Hold up. All right, James. Shh. Hang on, we got 8 minutes and a lot more questions. James. Find your way 200. Okay, please keep those chairs on all 4 legs. I don't want them to break. This type of map is best for studying terrain. Yeah, topographic map. Okay, if I gave you a topographic map, would you be able to read it? If I gave you, listen, if I gave you a topographic map and then images of the area it's actually mapping, would you be able to compare them and know which is which? Be able to do it. All right, Alex.
Break down 200.
Break down 200. Rocks high in this mineral are going to be less vulnerable to weathering.
The one from the yellow is there. Well, it's not my. It's not. No, but we need a mineral.
You guys back there be thinking in case you know it, just in case. You do know it? Okay.
What is quartz?
So we're looking for silica. Quartz is silica. So yeah, I'll give it to you. So, but what you need is silica. Quartz is super high in silica. It's like practically all silica, right? Remember those images that we saw of like, remember it was like granite and it was all eroded and there was this quartz vein like sticking out. Even some of the rocks I brought back from Nova Scotia looked like that. If I were to tell you you wanted to build a lasting monument to some amazing person that you know, like what would you make it out of? This would be great if you don't want it to ever go away. Yeah, quartz is great and marble is pretty good too. But that's a metamorphic thing. All right, last one. Whoops, I didn't mean to do that. Go away, we already did that. Okay, where are we going, James? Rocket 200. Light colored rocks are likely to be high in this mineral. Yes, you got it. Yes, yes, yes. We just talked about quartz. Quartz is nice and light. There you go. All right, Alex.
Blue planet 100.
Blue planet 100. The hydrosphere. What is it?
Basically, just say like
all the water on the planet combined.
Right. All the water in, on, and around the planet. Be sure that you are able to recognize that definition. You might maybe need to do like some matching. All right, James. How to Science 100. This is the approach to seeking knowledge that involves forming and testing a hypothesis in a logical, systematic way. What is the scientific method is correct. Boom. Next up, what's it going to be?
What is fair weather?
Fair weather 100. The gases surrounding the earth are known as this.
What is the atmosphere?
What is the atmosphere? Correct. Excellent. All right, what's next?
all around you 100.
All around you 100. This is the most abundant element in the universe.
Oh, yes, I know this one. Yes.
Not the atmosphere, the universe. What is it? What is hydrogen is correct. Why? Why do you suppose, why do you suppose that's the answer, Drew? Stars? Yeah. What? Yeah. What?
Everything in stars are 90%.
Yeah,
like that.
exactly. And there's lots of water on Earth that we got it here. We got lots of this hydrogen, but certainly within the universe, we have tons of hydrogen. This is Cole. Thank you, Cole, for visiting class. All right. You're supposed to bow.
100.
Which one? Find your way? 100. Okay, what's the geosphere?
Okay.
Biosphere is the northern thing.
No, I know that. I would I'm going off the thing that says what is physical Earth?
It's exactly spot on. Bailey, yes, we are talking about what is the physical Earth. 2 more. James. Rocket, 100. Crystals may form from this or from magma. There's lots of form froms there.
1, 3.
Evaporation. That is actually an answer. I need to make sure this one's a little more specific. But if you were to see this on the test, I'm looking for solution, but I'm going to give you credit for that one because evaporation's there. So I'm not sure. What is this one? Rocket 100. All right. You have too many points? No, you want less points? No, wait, that's not you. That's you. All right. Doesn't matter anyway. Last one is Alex.
Wait, I think we just had both of you.
Oh, okay. Wind erosion and stream erosion have these things in common. You were
They both approach
86.
things. They're both caused by fluid, both physical changes.
Mm-hmm.
They both break down rock.
What is all of those things?
Okay, what is all those things y'all just said? Okay, yes. So both involve erosion by fluids. That's your big one. But what does that mean? You got your particles. They move by saltation and suspension. You've got surface creep with wind and abrasion with water. Okay.
And then 3 question marks.
And then, yeah, well, that's because what is blah, 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 blah. All right. So in the next 2 minutes, I'm going to tell you real quick composition of your exam. Okay. Composition of your exam. You have 12, 34, either multiple choice or true false, fill in a letter. Okay. I mean, like fill in a letter, right? Okay. Then you've got labeling diagrams. One that's label a diagram for metric. It's the same you always have. If you've done it before, it's the metric one. You've got 1, 2, short answer on this page. This is got a map reading, 2 map reading questions. And then let's see, short answer 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 short answer. Reading a graphic, not a map. You got 6 of those. Actually 7, 8 of those. Then you've got you got matching. You got 1, 2 matching questions, and you have 2 extra credit questions. The first one is 3 points. The second one is 2 points. The 3-point one is 3 parts. It's identifying 3 separate things that might have been brought up today as like which was 1 and which was 2. 3 points. You're gonna have to know 3. So based on what I asked, you probably can figure out what the third is that we didn't go over today. 1, 2, 3. And then the other one is something that popped up today that was new, you haven't seen before, but you should be able to look at a map and figure it out. All right. It is 6 pages, your exam, and it has color images. So you should be good to go. Any questions before I dismiss you? Any questions at all about anything? No? All right, I'm going to correct those weird ones in here. And then you guys check your grade book. Make sure you're not missing anything. See you next week. Yes, sir. Get your change. Yes, sir.
That's right here. Yeah,
Trying to turn it around here, buddy. All right.
I didn't get much today.
Well, kind of like get a lot, less than short.
Most of that.
Alex, stop.
Okay.
I'm gonna warn you, whatever one he gave me was super sweet, and I thought that's like.
Ice cream.
That was ice
The
cream.
ice cream. Ugh, sounds awful. Ice cream, candy corn.
Good.
Here, let's see. What do you guys think?
It's really good.
Most
You
people
felt
are
much
voting
good.
for the blue one. All right,
You
we
voted
shall
for
see.
mine. Why? Why would you follow me?
You were the only one that voted.
The ice cream is
I
actually
just
very
told
good.
you that.
Sure. Yes, sir. Yep, I got him. I answered you back, but you were already here. I was working on those while y'all were over there. Y'all have 4 now. Excellent, excellent. Ozzy, good boy, baby. That's a good boy. Hey, sweet boy. Yes.
3.
School science. Which one is it? Earth. No, where's the one?
Chloe,
that's
you just
Earth?
stole one of mine? No, I can't pick my, I
Minutes,
picked.
Earth science midterm review.
Oh, just stole it. How could you?
Okay, PT. Oh no, that's rocket. 100.
Somehow that, yeah.